Alright, I wanted to show another approach for evaluating logarithms. And this approach works well for some of the more difficult ones. So for example, if we looked at this example here, evaluate the log base 100 of 1000. Our basic idea for logarithms says, well, let's say that it's equal to some number. Let's say that that logarithm is equal to some number. And then the idea is, well then 100, the base, to what number is 1000? Now that's fairly difficult. I can't think of a number, a simple number, 100 to that power is 1000. So our basic approach doesn't work well here. So let me show a different approach. Let's erase this. What I do notice is that 100 and 1000 are both powers of a number with the same base. So notice that 100 is 10 to the second power, and 1000 is 10 to the third power. Well, it turns out that I can rewrite this. So I have the log base 100 is 10 square of 1000 is 10 cubed. Now here's what I do. I take those new exponents. I take that 2 and I take that 3. And so this logarithm ends up being equal to the ratio of those two numbers. 3 over 2. The log base 100 of 1000 is 3/2. And we can verify this on a calculator if you'd like, but I won't at this time. And so the way to verify it is for you. Alright, so to verify this, try it out. Find 100 to the 3/2 power, and 100 to the 3/2 power is 1000. Alright, let's try another example. Alright, let me do, how about the one to the right? Let's evaluate the log base 125 of 1/25. This one's a little trickier. It's got a fraction in there. Oh, I've got to be careful here. Okay, but what I notice is 125 and 25 can both be written with base 5. Specifically, 125 is 5 to the third power. Now 1/25, well, here's what I remember. I know that 25 is 5 to the second, and so then remembering something about negative exponents, that means that 1/25 is 5 to the negative second power. So therefore, the log base 125 of 1/25, that's the log base 5 cubed of 5 to the negative second. And then again, what I'll do is I'll take the exponents. And so then this becomes -2 over 3, or more simply, -2/3. Now would be a good time to pause this video and try those other two exercises on your own. The log base 4 of 32. Well, what I notice is that 4 is 2 to the second, and 32, let's see, 2, 4, 8, 16, 32. 32 is 2 to the 5th power. So this is the same as writing the log base 2 squared of 2 to the 5th, and so taking the exponents, 5/2. The log base 4 of 32 is 5/2. The log base 81 of 27. Let's see, 81 and 27. I think I can write both of those with base 3. 81 is 3 to the 4th power, and 27 is 3 to the 3rd power. So this is the log base 3 to the 4th of 3 to the 3rd, taking the exponents. That's 3/4. Now the reason this works is because of something called the change of base rule, which is something that we'll see in a later section. But I thought I'd show you this approach for evaluating logarithms so you can tackle those trickier ones in the homework.